Assalamu alaikum friends, my name is Mushtaq and you are watching my YouTube channel Suninfotech. If you are new on my channel and you don't have subscribed my channel yet, please subscribe the channel and press the bell icon so that you may get notifications instantly whenever I upload new videos. Well friends, today I am in front of you with a new topic, that is logic gates. You must know, if you are a computer student or you are a physics student or you are an electronic student, so you must know about these logic gates, because these are the basic fundamental building blocks of an electronic circuit. Logic gates or the electronic circuits performing logic operations. These logic gates these are the basic fundamental building blocks of an electronic circuit, which is used in a computer system or any other gadget which is used for the calculation, for the arithmetics. These logic gates are the basic building blocks of an electronic circuit. These logic gates receives one or more inputs and gives output after performing the desired logical operation. Well friends, I know that this topic will not be completed in this only one lecture. I will make a series of lectures in which you will find all the solutions of this related topic. We have different kinds of logic gates. We have OR gate, we have AND gate, we have NOT gate, another gate is NOR gate, another one is NAND gate, and we have other gates like exclusively OR. We have. So guys, these are the different kinds of gates we are using in circuits. We are using in electronic circuits. This is our first gate we are discussing about. This is OR gate. This OR gate can take two or more inputs like this. I will make a truth table for its inputs. A, B, and this is output C. A plus B is equal to C. If input is 0 of A and another input is B 0, then the output will be 0 in terms of this OR gate. If this is 1, this is 0, output will be 1. If this is 0, this is 1, the output will be 1. If this is 1, this is 1, output will be 1. So we can say, in terms of this inputs, if input is there, if signal is there, if 1 is there, then the output will be yes in terms of this OR gate. If signal is not present in both the cases, then the output will be 0. So this gate requires input of one from one of the inputs. This OR gate is represented by this indication, this diagram, like this. These are the inputs. And this will be the output. These are two inputs, and it is representation. This is it is output. A plus B. Let us elaborate this thing by means of a circuit diagram, and you will understand the whole scenario of this OR gate. Like this, I will make a circuit diagram. This is a battery. This is a bulb here, like this. A, B, and this is C. Look at this circuit diagram. If both the switches are in open condition, the bulb will not glow. That is, if the signal is not there in both the cases, if the signal is 0, the bulb will not glow. It will not glow. If in one case, for example, when A is 0, this one, when A is 0 and B is 0, the bulb will not glow, right? If A is 1 and B is 0, the bulb will glow, like this. If A is 1 means switch is in closed position, like this. If A is 1, B is 0, bulb will glow. Here we get the signal. If A is 0, B is 1, like this. If A is 0 and B is 1 means switch is in closed position, like this. B is 1, A is 0. Bulb will glow. At this time, it will get the signal and the bulb will glow. Right? If A is 1, B is 1, it means that if the switch is in closed position at both the places, like this, in this case the bulb will glow. So we have seen that whenever there is an input, in case of this OR gate, we will get the output there. There will be an output signal. If there is no input in both the cases, in both these signals, if there is no input, then the bulb will not glow. It means that we are not getting any signal. This is the case with this OR gate. Hope you have understood this OR gate. If there is any question about this OR gate, please ask me the question in the comment box. Comment me and I will try to answer that question. Another gate is AND gate. Let us make it a truth table for AND gate. AND gate also takes two inputs and gives the output. Remember, only four these combinations are possible because we are using the binary. 2 raised to power 2 is equal to 4. That's why we are giving here only 4 combinations are possible. Right? So here the indication of this AND gate is, or the representation is this dot. A dot B is equal to C. Let's write its inputs 0 0 0 1 1 0 1 1. These are the inputs for this AND gate. Let us see what it does. Its representation is little bit different from this OR gate. We have to make here a clear D like this. Circuit diagram will also change. Let us go through this truth table right now. This is 0 and 0. 0 and 0 means 0. 0 and 1 means 0 in case of this AND gate. 1 and 0 is 0. 1 and 1 is 1. In case of this AND gate, only the result is possible, only the signal is 1 when both the inputs are 1. If one of the inputs is 0, there we will get no signal. We are getting 0 in case of this AND gate. So let us see with this circuit diagram this AND gate. Like this. This is our battery and these are the two switches, or we can say two inputs. This is A and this is B, and this is our output C. If A is 0, this is 0, 0 means in open condition. B is 0, B is 0 in open condition, then the output is 0. The bulb will not glow. The bulb will not glow like this. If A is 0, B is 1, means A is in this condition and B is in closed form. Switch is in closed form like this. A is 0, B is 1, switch is in closed form, but the light will not glow because here is cut, here is no signal. That's why this is 0 and 0 is 0. 0 and 1 is 0. Now A is 1, B is 0. If A is 1, B is 0, means like this. A is 1, B is 0. The bulb will not glow because the switch is open. This is 0. If A is 1, B is 1, like this. The bulb will glow. So it is clear that when both the inputs are 1, when there are two signals, the output will be 1. The output will be 1. Otherwise, in all the cases, the output will be 0 in terms of this AND gate. NOT gate. This NOT gate, it takes only one input. It takes only one input. It might be 0 or 1. And it reverses the input. It is an inverter. It reverses the input. It complements the input values. If the input is 1, it will result 0. If input is 0, it will result 1. It is logical representation is so. Thank you very much for watching this video. Thanks.